Welcome to the channel NextGen Tech Prep. In today's video, we are diving deep into essential questions and comprehensive answers for the Google Professional Cloud Architect certification. Whether you're preparing for an exam or just looking to sharpen your knowledge, you're in the right place. If you find this content valuable, please hit that subscribe button and ring the notification bell so you never miss an update. Now, let's get started.
Your company has hired an external auditing firm to perform a compliance audit. Your company's governance policy requires that external auditors be managed in a single Google group that is granted temporary, read-only access to a cloud storage bucket named Audit Evidence Bucket. Access must be traceable to the individual auditor's identity and be active only for the duration of the audit engagement, which runs the entire month of October. You need a secure access control strategy that avoids administrative overhead and complies with your company's governance policy. What should you do? The options are: Option A, apply an IAM policy binding that grants the roles/storage.object-viewer role to the Google group. Configure this binding with a time-based IAM condition that automatically grants access from October 1st to November 1st. Option B, create a service account and grant it the roles/storage.object-viewer role on the bucket. Generate and share signed URLs for each object in the bucket with an expiration date of November 1st. Option C, use Cloud Scheduler to run a Cloud Run functions script that adds the IAM binding of roles/storage.object-viewer to the Google group on October 1st and another that removes the IAM binding on November 1st. Option D, use Workforce Identity Federation to map the auditors group to the Google group. Bind the roles/storage.object-viewer role to this Google group. Configure a 1-month session duration on the provider.
To arrive at the correct answer, we focus on the keywords: managed in a single Google group, traceable to the individual auditor's identity, runs the entire month of October, avoids administrative overhead.
The correct answer is Option A, apply an IAM policy binding that grants the roles/storage.object-viewer role to the Google group. Configure this binding with a time-based IAM condition that automatically grants access from October 1st to November 1st.
Why is this correct? A. IAM conditions allow granting roles to a Google group with time-based constraints for October. This automates temporary access without administrative overhead while keeping access traceable to individual user identities in cloud audit logs. Why are the others incorrect? B. Generating signed URLs via a service account loses individual identity traceability in audit logs and adds heavy administrative overhead managing object-level access. C. Creating Cloud Scheduler jobs and Cloud Run functions introduces unnecessary operational overhead, custom code maintenance, and failure risks compared to native IAM conditions. D. Session duration controls identity provider login token lifespan, not scheduled IAM access boundaries for a specific month, introducing unnecessary identity federation overhead.
You are using a GitHub repository for your application's source code. You want to set up an efficient and secure continuous deployment process to automatically build and deploy the application to Cloud Run whenever a pull request is merged. What should you do? The options are: Option A, create a GitHub webhook trigger in Cloud Build. Once a pull request is merged, trigger Cloud Build to build a container image and save it in Artifact Registry. Use config sync to deploy the application to Cloud Run. Option B, create a workflow using GitHub Actions to build and deploy the application to Cloud Run once a pull request is merged. The workflow will use a service account key checked in with your source code for deployment permission. Option C, create a GitHub Enterprise trigger in Cloud Build. Once a pull request is merged, trigger Cloud Build to build and deploy the application to Cloud Run. Save the deployment credential to Secret Manager. Option D, connect your repository using the Cloud Build GitHub app. Create a trigger in Cloud Build. Once a pull request is merged, trigger Cloud Build to build and deploy the application to Cloud Run.
To arrive at the correct answer, we focus on the keywords: GitHub repository, automatically build and deploy the application to Cloud Run, pull request is merged.
The correct answer is option D. Connect your repository using the Cloud Build GitHub app. Create a trigger in Cloud Build. Once a pull request is merged, trigger Cloud Build to build and deploy the application to Cloud Run.
Why is this correct? D. Connecting the repository using the Cloud Build GitHub app and configuring a Cloud Build trigger provides a native, secure, and automated solution to build and deploy images to Cloud Run upon pull request merges. Why are the others incorrect? A. Webhook triggers add unnecessary complexity compared to the native GitHub app integration. Additionally, Config Sync is built for GitOps management of Kubernetes/GKE clusters, not serverless Cloud Run deployments. B. Checking service account keys directly into a source code repository violates core security best practices, exposing credentials and creating severe security vulnerabilities. C. GitHub Enterprise triggers are designated for self-hosted GitHub Enterprise server, not standard GitHub. Furthermore, Cloud Build uses native GCP IAM permissions rather than explicit deployment credentials stored in Secret Manager.
You are deploying a highly confidential data processing workload on Google Cloud. Your company's compliance framework mandates that cryptographic keys used for encrypting data at rest must be generated and stored exclusively within a validated hardware security module, HSM. You want to use a fully integrated Google Cloud managed service to handle the lifecycle and usage of these keys. What should you do? The options are: Option A, use customer-supplied encryption keys, CSEK, by providing your on-premises generated key with each API request. Option B, import your on-premises HSM key material into a Cloud KMS key with the software protection level. Option C, create a new key in Cloud Key Management Service, Cloud KMS, with the HSM protection level. Option D, configure Cloud External Key Manager, Cloud EKM, to connect to your on-premises HSM.
To arrive at the correct answer, we focus on the keywords: Hardware Security Module, HSM, fully integrated Google Cloud Managed Service, lifecycle, and usage of these keys.
The correct answer is option C. Create a new key in Cloud Key Management Service, Cloud KMS, with the HSM protection level.
Why is this correct? C. Cloud KMS with the HSM protection level, Cloud HSM, generates and stores keys directly inside FIPS 140-2 Level 3 validated HSMs, providing a fully integrated Google Cloud Managed Service for complete key lifecycle management. Why are the others incorrect? A. CSEK requires generating keys on premises and transmitting them with each API request, failing to provide a Google Cloud Managed Service for key lifecycle management. B. The software protection level stores keys in software memory, failing the compliance requirement to generate and store keys exclusively inside an HSM. D. Cloud EKM relies on an external on-premises HSM, which does not keep key generation, storage, and lifecycle fully within a Google Cloud Managed Service.
You are designing a central, automated infrastructure deployment process for your organization using Terraform and Cloud Build. The security team prohibits the use of long-lived, static service account keys in any CI/CD pipeline. Additionally, while developers can propose infrastructure changes for peer review, they must not have permissions to directly apply changes in the production project. You need to design a secure and automated workflow for applying Terraform changes that meets the security team's requirements and ensures proper governance. What should you do? The options are: Option A, configure the Cloud Build pipeline to use service account impersonation. Set up a trigger that automatically runs Terraform apply when a pull request is merged. Option B, use service account impersonation in Cloud Build. Configure the pipeline to run Terraform plan on pull requests, and require manual approval before running Terraform apply. Option C, configure the pipeline to only run Terraform plan. After a pull request is approved, have an authorized developer run Terraform apply from a secured workstation. Option D, create a privileged service account and store its JSON key in Secret Manager. Configure the cloud build pipeline to fetch this key during execution to authenticate Terraform.
To arrive at the correct answer, we focus on the keywords. Terraform and Cloud Build prohibits the use of long-lived, static service account keys, must not have permissions to directly apply changes, proper governance.
The correct answer is option B, use service account impersonation in Cloud Build. Configure the pipeline to run Terraform plan on pull requests, and require manual approval before running Terraform apply.
Why is this correct? B. Service account impersonation avoids static keys, satisfying security requirements. Running Terraform plan on pull requests provides visibility, while requiring manual approval before Terraform apply enforces proper governance and prevents unauthorized direct changes. Why are the others incorrect? A. Automatically running Terraform apply upon merging a pull request lacks a manual approval step, failing to enforce strict governance before production changes are executed. C. Requiring an authorized developer to run Terraform apply from a workstation introduces a manual, unautomated execution step and violates central CI/CD automation principles. D. Storing a service account JSON key in Secret Manager still uses long-lived static credentials, violating the security policy prohibiting static service account keys.
Your company is expanding its AI-powered operations nationwide and has chosen accelerator-based compute for the AI workloads. The batch image processing workloads are not time-sensitive and can tolerate interruptions. You need to rapidly deploy cost-effective accelerator nodes for these batch tasks, ensuring rapid deployment and data persistence when necessary. What should you do? The options are: Option A, deploy standard VMs with configured accelerators and attached persistent disks. Option B, deploy spot VMs with attached persistent disks and implement checkpoint mechanisms. Option C, deploy spot VMs with local SSD to reduce time for bursty workloads. Option D, deploy Cloud Run functions with ephemeral local SSD.
To arrive at the correct answer, we focus on the keywords: accelerator-based compute, not time-sensitive and can tolerate interruptions, cost-effective, data persistence.
The correct answer is option B, deploy spot VMs with attached persistent disks and implement checkpoint mechanisms.
Why is this correct? B. Spot VMs significantly reduce compute costs for fault-tolerant, non-time-sensitive workloads. Attaching persistent disks combined with checkpointing ensures data persistence and progress retention across VM preemptions. Why are the others incorrect? F. Standard VMs incur full compute costs, making them far less cost-effective for interruptible, non-time-sensitive batch processing workloads. C. Local SSDs are ephemeral and lose all stored data upon VM preemption, failing the requirement for data persistence. D. Cloud Run functions are designed for lightweight, event-driven execution rather than intensive accelerator-based batch workloads, and ephemeral storage does not guarantee data persistence.
Your organization is going to migrate applications to Kubernetes and use managed cloud services to deploy applications. Your team is new to Kubernetes and wants to quickly onboard engineers. You want to reduce operational overhead, so the engineering team can focus on developing consumer requirements instead of maintaining the infrastructure. What should you do? The options are: Option A, package your application into a Docker image and deploy it to Kubernetes on Compute Engine. Option B, leverage Cloud Build to create a container image and deploy it automatically to Kubernetes on Compute Engine. Option C, assess application and dependencies for containerization. Develop a migration strategy for deployment to GKE in standard mode. Option D, assess application and dependencies for containerization. Develop a migration strategy for deployment to GKE in autopilot mode.
To arrive at the correct answer, we focus on the keywords: new to Kubernetes, quickly onboard engineers, reduce operational overhead, developing consumer requirements instead of maintaining the infrastructure.
The correct answer is option D, assess application and dependencies for containerization. Develop a migration strategy for deployment to GKE in autopilot mode.
Why is this correct? D. GKE Autopilot Mode provides a fully managed Kubernetes environment where Google manages cluster infrastructure and node provisioning. This dramatically reduces operational overhead, allowing teams new to Kubernetes to focus on application development. Why are the others incorrect? A. Deploying self-managed Kubernetes on Compute Engine requires manual infrastructure setup, node management, and control plane maintenance, creating substantial operational overhead. B. Using Cloud Build to deploy to self-managed Kubernetes on Compute Engine still leaves node maintenance and cluster management responsibilities with the team, failing to minimize operational burden. C. GKE Standard Mode requires manual configuration and maintenance of node pools and infrastructure settings, resulting in higher operational overhead than Autopilot Mode.
Your company runs a critical, revenue-generating e-commerce application that is served by a regional managed instance group, MIG, behind an external HTTP/S load balancer. The operations team is currently overwhelmed with low-priority notifications and is starting to ignore alerts. Your team's service level objective, SLO, is to maintain 99.9% availability, which is measured by the ratio of successful requests, 2xx status codes, to total requests. You want to minimize noise from non-critical events and ensure that the team is only notified of issues that are actionable and threaten the SLO. What should you do? The options are: Option A, focus on cause-based alerts, creating alerting policies with thresholds for the Compute Engine instances, including CPU utilization, memory usage, disk I/O, and network traffic. Option B, create log-based alerts for only the warn and error log entries generated by the application to ensure that no potential issue is missed. Option C, implement an error budget policy based on the availability of the SLO. Create a page alert that triggers only when the rate of burn of the error budget predicts a full exhaustion within the next 24 hours. Option D, configure alerts based on predictive metrics. Use the instance count of the MIG as the primary metric to trigger an alert.
To arrive at the correct answer, we focus on the keywords: overwhelmed with low-priority notifications, service level objective, SLO, minimize noise from non-critical events, threaten the SLO.
The correct answer is option C, implement an error budget policy based on the availability of the SLO. Create a page alert that triggers only when the rate of burn of the error budget predicts a full exhaustion within the next 24 hours.
Why is this correct? C. SLO-based alerting using error budget burn rates ensures notifications are triggered only when issues threaten to exhaust the SLO budget, eliminating alert fatigue and non-actionable noise. Why are the others incorrect? A. Cause-based alerting on infrastructure metrics creates significant alert fatigue with non-actionable noise, as high resource utilization does not necessarily indicate user-impacting failures or SLO breaches. B. Log-based alerts for warn and error entries generate excessive noise from transient application warnings, worsening alert fatigue without directly correlating to SLO availability breaches. D. Alerting on instance count or predictive metrics fails to measure actual user success rates and generates unnecessary notifications during routine auto-scaling operations.
You manage a highly distributed, hybrid and multi-cloud IT environment, and your developers rely heavily on Prometheus for their workflows. You need a cloud-based, highly scalable, low-maintenance enterprise solution that supports Prometheus query language, PromQL, queries, quick metric viewing, and efficient issue diagnosis. What should you do? The options are: Option A, deploy a Prometheus operator in your existing Kubernetes and serverless setup across multi-cloud environments. Option B, set up cloud monitoring as a single pane of glass across multi-cloud environments. Option C, enable Google Cloud Managed Service for Prometheus to monitor and alert on your workloads at scale. Option D, build a SaaS-based, Prometheus-compatible solution to display metrics for each cloud in a customizable way.
To arrive at the correct answer, we focus on the keywords: hybrid and multi-cloud IT environment, Prometheus, low-maintenance enterprise solution, Prometheus query language, PromQL.
The correct answer is option C. Enable Google Cloud Managed Service for Prometheus to monitor and alert on your workloads at scale.
Why is this correct? C. Google Cloud Managed Service for Prometheus provides a fully managed, highly scalable multi-cloud solution that natively supports PromQL, allowing teams to preserve existing Prometheus workflows with minimal maintenance overhead. Why are the others incorrect? A. Deploying self-managed Prometheus operators across multi-cloud environments introduces high operational overhead and complex management, violating the low-maintenance requirement. B. Cloud monitoring alone without managed service for Prometheus does not natively integrate existing Prometheus configurations or PromQL workflows across multi-cloud workloads. D. Building a custom SaaS solution requires significant engineering effort and ongoing maintenance, directly contradicting the requirement for a low-maintenance enterprise solution.
Your organization uses Google Kubernetes Engine, GKE, and Amazon Elastic Kubernetes Service, EKS, to manage a complex Kubernetes environment across multiple cloud providers. You need to deploy a solution that streamlines configuration management, enforces security policies, and ensures consistent application deployment across all of the environments. You want to follow Google recommended practices. What should you do? The options are: Option A, leverage Argo CD for GitOps-based continuous delivery and Open Policy Agent, OPA, for policy enforcement, and develop a controller for multi-cluster configuration management. Option B, deploy Crossplane for managing cloud resources as Kubernetes objects, Flux CD for GitOps-based configuration synchronization, and Kyverno for policy enforcement. Option C, deploy Kustomize for configuration customization, config sync with multiple Git repositories, and a script to enforce security policies. Option D, utilize config sync as part of GKE to synchronize configurations from a centralized repository, and utilize Policy Controller to enforce policies using OPA Gatekeeper.
To arrive at the correct answer, we focus on the keywords: Google Kubernetes Engine, GKE, and Amazon Elastic Kubernetes Service, EKS, streamlines configuration management, enforces security policies, Google recommended practices.
The correct answer is option D. Utilize config sync as part of GKE to synchronize configurations from a centralized repository, and utilize Policy Controller to enforce policies using OPA Gatekeeper.
Why is this correct? D. Config sync enables GitOps-based configuration management across GKE and EKS multi-cloud environments, while Policy Controller enforces security policies using OPA Gatekeeper, fully adhering to Google recommended practices. Why are the others incorrect? A. Developing a custom controller creates unnecessary operational overhead and complexity, violating Google recommended practices when managed tools like Config Sync and Policy Controller are available. B. Flux CD, Crossplane, and Kyverno are third-party open-source tools rather than Google-recommended native solutions for multi-cluster configuration sync and policy enforcement across GKE and EKS. C. Using custom scripts to enforce security policies is manual, error-prone, and non-declarative, whereas Google recommends Policy Controller for automated, continuous policy enforcement.
Your company is rapidly deploying containerized microservices on Google Kubernetes Engine, GKE, using a robust CI/CD pipeline. Security is a top priority, and you need to implement a comprehensive and efficient strategy to prevent container image vulnerabilities from reaching your GKE production environment. What should you do? Choose 2. The options are: Option A, review the security reports generated by artifact analysis for each container image before deployment to GKE. Option B, incorporate vulnerability scanning before building container images, and use Google-maintained base images for your container deployments. Option C, enable artifact analysis for the container images, and stop deployment if critical vulnerabilities are found. Option D, Use a custom security policy within your container image that restricts access to specific network ports and resources. Option E. Enable shielded GKE nodes on the production cluster to automatically block the execution of container images with known vulnerabilities.
To arrive at the correct answer, we focus on the keywords Google Kubernetes Engine, GKE, Prevent Container Image Vulnerabilities, GKE Production Environment, choose 2.
The correct answers are option B, incorporate vulnerability scanning before building container images, and use Google-maintained base images for your container deployments. And option C, enable artifact analysis for the container images, and stop deployment if critical vulnerabilities are found.
Why is this correct? B. Scanning dependencies prior to image builds and utilizing secure, Google-maintained base images reduces security risks early in the development lifecycle. C. Enabling artifact analysis provides automated vulnerability scanning and artifact registry, allowing the CI/CD pipeline to automatically block deployments when critical vulnerabilities are detected. Why are the others incorrect? A. Manually reviewing security reports is slow, inefficient, and counterproductive for rapid, automated CI/CD deployment pipelines. D. Custom security policies within images manage runtime permissions but cannot detect or block vulnerable images from reaching production. E. Shielded GKE nodes ensure node boot integrity and defense against rootkits, but do not scan or block container images with vulnerabilities.
Your organization is implementing a new cloud-native application on Google Cloud and needs to ensure compliance with the ISO/IEC 27001 framework. You want to leverage Google Cloud security reports and documentation to support your ISO/IEC 27001 audit process. What should you do? The options are: Option A. Engage an independent auditor to conduct an ISO/IEC 27001 audit of your organization's Google Cloud implementation. Option B. Download the ISO/IEC 27001 report for Google Cloud through Internet search. Option C. Review the Compliance Reports Manager for information about ISO/IEC 27001 compliance and related documentation on obtaining reports through your Google Cloud account. Option D. Utilize the Cloud Audit Log service for accessing and requesting the ISO/IEC 27001 reports.
To arrive at the correct answer, we focus on the keywords ISO/IEC 27001, Google Cloud Security Reports and Documentation.
The correct answer is option C, review the Compliance Reports Manager for information about ISO/IEC 27001 compliance and related documentation on obtaining reports through your Google Cloud account.
Why is this correct? C. Compliance Reports Manager provides centralized access to Google Cloud's official compliance documentation, security reports, and third-party audit certificates, including ISO/IEC 27001 reports required to support customer audit processes. Why are the others incorrect? A. Auditing your organization's implementation does not satisfy the requirement to leverage Google Cloud's own pre-existing security reports and ISO/IEC 27001 compliance documentation. B. Google Cloud Compliance Reports contain sensitive information and should be accessed securely through official Google Cloud channels rather than downloaded from unverified Internet search results. D. Cloud Audit Logs records user and administrative activities within your Google Cloud projects. It is not used to access or request Google's third-party compliance reports.
You are monitoring Google Kubernetes Engine, GKE, clusters in a cloud monitoring workspace. As a site reliability engineer, SRE, you need to triage incidents quickly. What should you do? The options are: Option A. 1. Navigate the predefined dashboards in the cloud monitoring workspace. Point 2. Add metrics and create alert policies. Option B. 1. Write a shell script that gathers metrics from GKE nodes and publish these metrics to a pub/subtopic. Point 2. Export the data to BigQuery and make a Data Studio dashboard. Option C. 1. create a custom dashboard in the Cloud Monitoring Workspace for each incident. Point 2. Add metrics and create alert policies. Option D. 1. Navigate the predefined dashboards in the Cloud Monitoring Workspace. Point 2. Create custom metrics and install alerting software on a Compute Engine instance.
To arrive at the correct answer, we focus on the keywords Google Kubernetes Engine, GKE, Cloud Monitoring Workspace, triage incidents quickly.
The correct answer is option A. 1. Navigate the predefined dashboards in the Cloud Monitoring Workspace. Point 2. Add metrics and create alert policies.
Why is this correct? A. Cloud monitoring provides built-in predefined dashboards for GKE that offer immediate operational visibility out of the box, allowing SREs to triage incidents quickly. Adding metrics and native alert policies enables automated monitoring without operational overhead. Why are the others incorrect? B. Writing custom shell scripts and exporting metrics through pub/sub and BigQuery to Looker Studio adds significant development overhead, architectural latency, and operational complexity, which slows down incident triage instead of leveraging existing GCP monitoring capabilities. C. Creating a new custom dashboard for every incident during triage is inefficient and time-consuming. Predefined GKE dashboards in cloud monitoring are immediately available, facilitating rapid triage without manual setup during outages. D. Installing third-party alerting software on Compute Engine introduces unnecessary infrastructure management and maintenance overhead. Cloud monitoring includes native alerting policies designed to work directly with GKE and workspace metrics.
The JenkoMart security team requires that all Google Cloud Platform infrastructure is deployed using a least privilege model with separation of duties for administration between production and development resources. What Google domain and project structure should you recommend? The options are: Option A. Create 2 G Suite accounts to manage users, one for development/test/staging and one for production. Each account should contain one project for every application. Option B. Create 2 G Suite accounts to manage users, one with a single project for all development applications and one with a single project for all production applications. Option C. Create a single G Suite account to manage users with each stage of each application in its own project. Option D. Create a single G Suite account to manage users with one project for the development/test/staging environment and one project for the production environment.
To arrive at the correct answer, we focus on the keywords least privilege model, separation of duties, production and development resources.
The correct answer is option C. Create a single G Suite account to manage users with each stage of each application in its own project.
Why is this correct? C. A single G Suite domain provides centralized identity management. Separating each stage of every application into its own project enforces strict resource isolation, enabling fine-grained IAM role assignments for least privilege and separation of duties. Why are the others incorrect? A. Using multiple G Suite accounts unnecessarily fragments user identity management across domains. Identity management should be centralized under a single G Suite account while separating environments using projects. B. Creating multiple G Suite accounts fragments identity management. Additionally, placing all development or production applications into a single project prevents granular IAM access control and resource isolation between applications. D. Combining all applications into single projects per environment prevents fine-grained IAM permissions and resource isolation between distinct applications, failing the least privilege requirement.
A few days after JenkoMart migrates the user credentials database to Google Cloud Platform and shuts down the old server, the new database server stops responding to SSH connections. It is still serving database requests to the application servers correctly. What 3 steps should you take to diagnose the problem? Choose 3. The options are: Option A. Delete the virtual machine, VM, and disks and create a new one. Option B. Delete the instance, attach the disk to a new VM, and investigate. Option C. take a snapshot of the disk and connect to a new machine to investigate. Option D, check inbound firewall rules for the network the machine is connected to. Option E, connect the machine to another network with very simple firewall rules and investigate. Option F, print the serial console output for the instance for troubleshooting, activate the interactive console, and investigate.
To arrive at the correct answer, we focus on the keywords, stops responding to SSH connections, serving database requests to the application servers correctly, choose 3.
The correct answers are option C, take a snapshot of the disk and connect to a new machine to investigate, and option D, check inbound firewall rules for the network the machine is connected to, and option F, print the serial console output for the instance for troubleshooting, activate the interactive console, and investigate.
Why is this correct? C. Taking a disk snapshot creates a copy without taking down the running production database, allowing you to attach the snapshot volume to a separate VM for forensic inspection. D. Checking inbound firewall rules helps verify whether SSH port 22 traffic is inadvertently blocked at the VPC firewall level while database traffic remains allowed. F. Viewing serial console output and enabling interactive serial console allows out-of-band access to troubleshoot OS-level SSH failures on a live running instance without network SSH. Why are the others incorrect? A. Deleting the VM and its disks causes permanent data loss and unnecessary downtime for a database that is actively serving production traffic. B. Deleting the instance causes production service interruption while the database is actively handling live application requests correctly. E. GCP does not support moving an active VM's primary network interface dynamically, and altering network settings disruptively affects live database traffic.
Gencomart has decided to migrate user profile storage to Google Cloud Data Store and the application servers to Google Compute Engine, GCE. During the migration, the existing infrastructure will need access to Data Store to upload the data. What service account key management strategy should you recommend? The options are: Option A, provision service account keys for the on-premises infrastructure and for the GCE virtual machines, VMs. Option B, authenticate the on-premises infrastructure with a user account and provision service account keys for the VMs. Option C, provision service account keys for the on-premises infrastructure and use Google Cloud Platform, GCP, managed keys for the VMs. Option D, deploy a custom authentication service on GCE/Google Kubernetes Engine, GKE, for the on-premises infrastructure and use GCP managed keys for the VMs.
To arrive at the correct answer, we focus on the keywords Google Cloud Data Store, Google Compute Engine, GCE, Service Account Key Management Strategy.
The correct answer is option C, provision service account keys for the on-premises infrastructure and use Google Cloud Platform, GCP, managed keys for the VMs.
Why is this correct? C. On-premises systems outside GCP require user-managed service account keys to access Cloud Data Store. Compute Engine VMs should leverage GCP managed keys via attached service accounts, avoiding manual key rotation and reducing security risks associated with exported service account keys. Why are the others incorrect? A. Provisioning user-managed service account keys for Compute Engine VMs is unnecessary and insecure. GCE VMs should use GCP managed keys attached directly to the instances, which eliminates manual key management overhead and rotation risks. B. Automated infrastructure operations and data migration from on-premises systems should use service accounts rather than user accounts. Furthermore, GCE VMs should rely on GCP managed keys rather than exported service account keys. D. Building and maintaining a custom authentication service on GCE/GKE introduces redundant operational complexity and security risks for an on-premises migration task, whereas standard user-managed service account keys are designed specifically for this purpose.